Hello everyone, my name is Carolina Surratt. Welcome to Lesson 2, Descriptive Statistics. Today we will cover one of two short topic videos. So without further ado, let's get started. The listing below gives the service times in minutes for a sample of customers who arrive at the drive-in service window of A&W. So right here we have all our data points. Question A asks, construct a stem and leaf display for the service times. So before we get started, the very first thing to do, which is very important, okay, so number one, always, we have to order our data. Okay, and what I mean by this is simply to put it from smallest to biggest. Whoops. Okay, so let's go ahead and do that. All right, so here we go. Our data is fully ordered. So as you can see, we go from smallest to biggest. So this is definitely your number one step. Every time you have a problem like this, make sure that your data is in order. It'll just make your life a lot easier. So now that we have this taken care of, we can now go ahead and build our stem and leaf display. So I'm going to go ahead and draw my stem. Now the way the stem and leaf display works, on the left-hand side, we will always have, here we see that the data goes from 0, and the greatest number is 8. So we're going to plot from 0 all the way to 8, because we know those will be the unit measurements that we will require. Okay. Now, number 2 that we need to determine is our leaf unit. So how do we determine the leaf unit? It's very simple. Let's say we take this data point right here, 7.96. Okay. If I know that I have 7 on the left-hand side here of my stem, and on the right-hand side, the leaf would be 96. What do I have to multiply 796 by to obtain 7.96? Okay, so this is the method we use. So what should go on this side right here? We know that if we take 0.01, multiply it by 796, we obtain 7.96. So I know that my leaf unit is going to be 0.01. So we have our leaf unit. Which will equal 0.01. So I repeat one more time. The way to do this is you take the data from your stem and leaf and you pluck it out just like that. So this gives us 796, so 796. And we ask ourselves, by what do I have to multiply this by to obtain the data point right here, which is the one in my data set, which is 7.96, and that is by 0.01. So that is my leaf unit. So let's go ahead and build the stem and leaf in order. So here we would have 26, 45, 52, 81, and 85, 88, 91, and 94. So let's go ahead and fill in the rest. So 796, and finally 881. So here we go. This would be the final product of our stem and leaf display. So let's recap a couple of things. Number one, like I mentioned, make sure that your data is in order. It's very important. If not, it can create a lot of confusion in the actual stem and leaf display. And number 2, the leaf unit, I'll redo it one more time just because I think it's really important. So let's say I select any data point. Let's take this one right here. So if I extract this from the stem and leaf display, what do I have? I have 491, okay? Just 491, that's all. And what I have to ask myself is, what do I have to multiply 491 by? So what do we have to multiply it by to obtain the data point that is right here, which is 4.91. Okay? So this is some simple math. If we divide 491 by 4.91, we get 0.01. Okay? So don't forget that little rule. It always works, and this will help you determine your leaf unit right here, which will help you build your stem and leaf display. So now part B, it asks us, complete the following descriptive statistics. Question 1, they want the mean, the median, and the mode. Question 2, the first and third quartiles. Question 3, the range and interquartile range. And finally, in point 4, they want the variance and the standard deviation. So let's get started with the mean, the median, and the mode. So the first one asks us for the mean. Okay? So we all know the mean is simply the sum of all of our x's, so all the values here within our data set, divided by the total number of values. So to do this, we're just going to switch over to the calculator real quick. So 0.26 plus 0.45 All right, so let's see what this gives us. A total of 80.65. So let's go ahead and write that on our sheet. So this is, so the total of the sum of all our values is 80.65. And we know that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 values. So our sample size is of size 30. So now we're just going to divide through. And this gives us a total of 2.68. So that is our mean, which, because this is a sample, can also be written as x bar. Okay? So the second thing we want is the median. So there are two things to remember in the median. The first is we have to calculate the position. We know that the median is always the 50th percentile. So what we're looking to calculate first is what position is the 50th percentile. And this can be done in two ways. So we can either do I, okay, so the ith position divided by 100. And in the median's case, that is 50 divided by 100, which we will then multiply by the sample size. Okay? So this is equal to 0.5, which is 50 over 100, multiplied by 30, which is our sample size. And so this gives us the 15th position. Okay? Now, as you all learned in class, when we have an even position, which here is 15, we must take the average of the 15th and the 16th position. Okay? So I'll put this over here. So when we have an even numbered position, to determine the median, we have to take the average of, okay, so the median is, in this case, the average of the 15th and the 16th position, which we will divide by 2. So that gives us, so let's calculate what the 15th and the 16th positions are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so let's just circle that. So this here is our 15th position, and this here is our 16th position. Okay, so once again, 16th position, and this is our 15th position. So we have the average of 2.25 plus 16th position, which is 2.33. This divided by 2. So our median is, so let's just switch over to our calculator real quick. So it's 2.25 plus 2.33. And this will be divided by 2, which gives us 2.29 for our median. Okay, so this gives us 2.29 for our median. So that's how we determine the median for an even numbered position. Now let's say, and this is just for example purposes, okay? So I'm just going to put these dotted lines so you know that this has nothing to do with the problem we're doing right now. It's just to show you what the other scenario would be. Okay, so let's say we have a sample size of 31, okay? Which isn't the case here, as you know. So if our sample size is 31, to find the median, we know that it is the 50th position. So it's always the 50th percentile, always, always, always. So let me show you the second way. So what I showed you first was the ith position divided by 100, which in the median's case was 50 divided by 100. So the median's position is n divided by 2, okay? So it's 31 divided by 2, which is equal to 15.5, okay? Now, when we encounter an uneven number, so anything that has a decimal in it, whether it's 15.1, 0.2, 0.3, 0.4, most often it will be 0.5 because we'll always have integer sample sizes. What do we do in this case? Very simple. We know that the median's position is 15.5, so we will simply round up to the 16th position, and this value at the 16th position will be our median. Okay, so this is my position, and so the value will equal, so we already know what the 16th value is from the prior example, it will be 2.33. So notice how it does make a difference. Before it was the average of these two right here, which gave us 2.29, but for an uneven sample size, we have to take the position that's given to us, which is 15.5, and round up to the next position. So that would be 2.33 would be the median value. Okay, so quick recap. 2 ways to solve for the median. This is really specific to the median. We would have the n divided by 2 for the position, or I divided by 100, in which case the ith position for the median is the 50th percentile. Okay, so this is the position, and this is here the value. Okay, so be very careful. There's those 2 steps. Now let's find the mode. The mode is very simple. The mode is simply the value that is repeated the most often. So here we can see that the only value that is repeated more than once is 2.95. We have 2.95 once, 2.95 twice. So that is our mode. Our mode is equal to 2.95. Now, one thing to bear in mind, there cannot be more than one mean. There cannot be more than one median. There can, however, be more than one mode. Okay? It is the only measure of central tendency that can have more than one value. So now let's move on to the second part where they want us to find the first and third quartiles. So this will be a great review of the median. So let's start with the first quartile. The first quartile is equal to the 25th percentile. Okay. And so as we saw previously, first we need to find the position. So that is I divided by 100, where I represents the percentile. So that's 25 divided by 100, which equals 0.25. And we will multiply this 0.25 by our sample size in order to get our position. So that's 0.25 times 30, which is equal to the So let's switch over to our calculator real quick. Okay, so 0.25 multiplied by our sample size. So this is a position of the 7.5 position. Now, as we saw previously, we know that 7.5 means that we have to round up. So we know that the position of 7.5, we simply round up to the 8th position. And so our value will be at the 8th position, and that is 1, 2, 3, 4, 5, 6, 7, 8, right here. So the 8th position value is 0.94. So that is our first quartile, which is also known as, and this will be useful for our box plots, as Q1. All right, so now let's solve for the third quartile, which is the 75th percentile, or Q3. Okay, so as always, first we need to find our position. And notice how we can't do simply n divided by 2 here. That only applies to the median, because the median is the 50th percentile, which is exactly your sample size times 0.5, or your sample size divided by 2. Mathematically, it's the same outcome. Here, it's a little bit more complicated for Q1 and Q3, so the easiest thing is really just to take, in this case, 75 divided by 100, which was our I divided by 100. So the ith position is our 75th percentile, which we will multiply by our sample size, which is 30. So this is 0.75 times 30, which equals, so let's just switch over to our calculator. So this is the 22nd 0.5 position. And we know that when we have an uneven number, so 22.5, when we have decimals, we'll simply round up, and this will be the value at the 23rd position. So for our value, so we will look for the value at the 23rd position, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So our value here is 3.51, which is right here at the 23rd position. All right, so now let's compute the range. Okay, so the range is quite simple. It's always the largest value minus the smallest value. Okay, now what I mean by this, let's illustrate it. So the largest value is our So the largest value is 8.81, whereas the smallest value, okay, is simply our smallest data set, which is 0.26. So now, if we do one minus the other, we obtain our range, which is 8.55. Okay, that's simply it. And we'll go ahead and do the interquartile range. Okay, it's quite the mouthful. So interquartile range, otherwise known as IQR. Okay, so we have here interquartile range, IQR, and this is simply Q3 minus Q1. So our 75th percentile minus our 25th percentile, which in this case we've already computed. So we simply write them down again. So it's going to be 3.51 minus 0.94, and this gives us a total of 2.57. Okay, so there you have it. And finally, we need to calculate the variance and a standard deviation. So let's start with the variance, from which we will easily be able to deduce the standard deviation. Now the formula for the variance is as follows. Okay. Now the reason why I'm writing s squared and not sigma squared is because this is a sample. It's a sample of size 30. It is not a population. So for samples, we will use s. And for populations, we will use sigma. So I'll just write it here real quick before it reads. So population and samples, okay? So just make sure you grab the right one because notation is important. So let us compute the variance. So our variance, s squared, is equal to the sum of all the differences between our x's and the sample mean squared, entire thing divided by n minus 1. Two things. First of all, this right here at the top, x minus x bar, is the dispersion between the values. So let's say, for example, our sample mean, we know it to be at 2.69. 8.81 is quite a few numbers away from 2.69. So there's a dispersion between this value right here at 8.81 and our mean at 2.69. And that is what the variance calculates, how much all the values within our data set vary from the mean, which is the average, which is essentially what is expected. The reason why we square it is because if we didn't, all the values would cancel each other out. We would have negative values below the mean and positive values above the mean And so in the end, they would cancel each other out. So we square it to make sure that we take into account the entire range of error. And finally, the reason why we divide by n minus 1 and not only n is because, as I mentioned earlier, this is a sample, not a population. And so what n minus 1 does is it decreases the value of our denominator, and thus it increases the value of our variance or our error, which is normal because a sample will never be as accurate as the population. So by doing n minus 1, we're increasing the error slightly. Before computing in the calculator, what I'd suggest you do, at least for the first ones, is to make a few columns. So you'll have all your x values. We won't put them all in, it's just for sake of example. So let's say we have 0.26, and then we would have x minus our mean. So we would have here 0.26 minus 2.69. And then you would have a third column, which is that value squared. Okay. And finally, at the very end, we would be able to take the sum of all these values. Okay. It seems tedious at first, but it's a quick way to make sure that you're doing it right for the first few times. So let's go ahead and compute all this. So this gives us 0.26 minus 2.69. So it gives us negative 2.43, which we will then take to the power of 2 to remove the negative sign. And this gives us 5.9049. Okay. So we'll just go ahead and write that here. So 5.9049. So then we would repeat the process for all 30 data values. Okay. So I'll just write this down real quick for a second time. So 0.45. So here we would have 0.45 minus 2.69, and then take it to the power of 2. So let's do that real quick in our calculator. 0.45 minus our mean, 2.69. And to remove the negative sign, we would take it to the power of 2. So this gives us 5.0176. And let's do one final one. We'll do it on the positive side, just so you guys know that even on the positive side, we still have to do it to the power of 2. So we would have 8.81 minus 2.69. So let's just switch over one more time. 8.81 minus 2.69. So that's 612. And we would still take this to the power of 2 regardless of it being positive. So this gives us 37.4544. Okay. Now I'm just doing 3 here, but obviously you need to do it for all 30. And at the very end, we would add this entire column up right here. And this, so the sum of this entire column would give us a total of approximately 136.01. So we'll take this up here. So 136.01, which we will divide by 29, which is our sample size of 30 minus 1. And this gives us a total of 136.01 divided by, and then we would have our sample size of 30 minus the 1, don't forget that, which would give us a total of 4.69. So that is our variance. Now we need to compute the standard deviation. So I'm just going to erase this on the right-hand side because the standard deviation, once you have the variance, is actually quite simple. Okay, so let's just get rid of this real quick. All right, so now the standard deviation as you all know, the standard deviation is simply the square root of the variance. Okay? So S would equal the square root of the variance, or if we write, this is the formula that most of you are used to seeing. So once again, we have the sum of the differences squared divided by n minus 1, but here we already have the variance value, so we simply do S is equal to the square root of 4.69, and we'll switch over to our calculator real quick. So we will do the square root of 4.69, which gives us 2.165. We can simply round to two numbers, that's not a problem. So this gives us 2.17, and there you go. And finally, question C, they want us to draw the box plot and identify any outliers. So let's get started. All right. So the box plot is composed of a few items. We're going to need the 5-point summary, and what is our 5-point summary? Our 5-point summary, first we need the largest value, we need the smallest value, we need our Q1, we need our Q3, and we need our median. Okay, so that is when they ask you in an exam, say for example, for the 5-point summary, before drawing your box plot, they're referring to the largest value, the smallest value, Q1, Q3, and the median. Okay, so let's just make sure this is, okay, so very important. So with that, we can then draw our box plot. So let's first draw our axis. Wonderful. So now that we have our axis, we need to determine what the higher and lower end of our axis is going to be. To do that, we first need to compute our fences. Now there's two fences, obviously, the lower fence and the upper fence. So let's start with the lower fence. Now, the lower fence is simply Q1 minus 1.5 times the interquartile range. Okay. So we have Q1, we know is 0.94. And to this we will subtract 1.5 times 2.57, which was our interquartile range. And this gives us, this gives us a total of so we have 0.94 minus 1.5 times 2.57, which gives us negative 2.92. So let's go ahead and write that. Oops, what happened? Okay. So let's go ahead and write that over here. So that's negative 2.92. And now we need our upper fence. So we will repeat a similar process. Our upper fence is going to be Q3 this time, plus 1.5 times IQR. And this gives us 3.51 plus 1.5 times 2.57. Let's get stuck at the end. 2.57. And this gives us 7.56. So that is our upper fence at 7.56. So now we have our lower end and the upper end of our axis. Okay. So let's go ahead and draw everything. So we know that this goes to about -3, -2, -2, So the first thing we will draw is our box. So the center line of our box is our median, which, as we all know right here, was at 2.29. So let's go ahead and draw that right about here. So this is our median. The next thing we need is our Q1, which, as you all know, is 0.94. So let's go ahead and draw that right around here. So this is our Q1. And finally, we need our Q3, which is at 3.51. So let's draw that right about here. So that is our Q3. So this represents our box. So now that we have our box, we need our whiskers. How do we determine the whiskers? Very simple. Our whiskers are the last data point before we fall out of the fence. So those are the limits of our whiskers. So I'll illustrate. So we know that our upper fence is at 7.56. So that falls somewhere around here. Okay, so that is our upper fence. Now, the last point before we hit our upper fence of 7.56 is 6.71. So let's go ahead and draw that. We know that before hitting the fence, the last point is going to be right around here at 6.71. So that is the limit for our whisker. So right here, I'm just going to put a little note at 6.71. Now, let's do the left-hand side. We know that the lower fence is at -2.92, so that is right around here. So that is my lower fence. And I want to know what is the last data point before I hit the fence. So the last data point here, it actually goes all the way till our smallest value, which is at 0.26. So that is right around here. So that is the limit for our whisker. So 0.26. Now, they ask us to identify any outliers. How do we do that? We know that on the upper side, the fence is at 7.56. and the last point before we hit the fence is right here at 6.71. So what do we do with these last two values, the 7.96 and the 8.81? Well, quite simply, they are outliers. So our first one will be right here at 7.96, and our second one will be right here at 8.81. So make sure you circle these so we don't think it is just a little dot and we know that they are outliers. You can even identify them if you want. Okay, so these two right here would be our outliers. So let's do a quick recap. We have our box, which is made up of our 25th percentile, or our Q1, our median, which is our 50th percentile, and our Q3, which is our 75th percentile. Then we have our whiskers. How do we determine the limit for our whiskers? It's very simple. Once we find our upper fence and our lower fence, we need to determine the last point before we hit the fence. So that would be on the right-hand side, 6.71, and on the left-hand side, it goes all the way till the end at 0.26. But on the right-hand side, that leaves us with 2 points, 7.96 and 8.81. And because they are beyond the fence, they are considered outliers. So that is it for this short topic video. I hope you all enjoyed, and good luck studying.